let's go ahead and get rolling on this month's Stuck in a Bucket webinar. All righty. I think most of you know me by now. Have listened to me drone on and on through a few of these webinars. If not, I'm Fritz Wichern, one of the sales engineers for KMC Controls. I'm joined today by Gene Stutzman, who is our subject matter specialist and expert on all things KMC, at least much smarter than I am with it. So as a point of note here, Gene is actually on a bucket doing some real work today. So you don't get to see his shiny face on a camera, but he's here with us and will be correcting me when I, add any goofy or incorrect comments here. So, all right, this month we're going to be talking about looking at our factory supplied programs that come in our, standard applications. And, kind of a review of some of these. I think most of you have probably used them and know of them, but we're kind of going to breeze through them. I've talked to a few folks in the last couple of months that didn't seem to know or realize what was there. So we're just going to touch on some of those, and then at the end we'll open up, connect, and look at a couple details of how to use some of these standard applications and that you can add on to those using the Conquest line of controllers. Let's see, I don't have a name, but I promise we are getting winners each month for these KMC Yeti cups. So don't worry, if you haven't gotten one yet, hang in there, your month will come. To start off here, in case you have any questions on where you can find some of these sequence details, you can go out on our website. Of course, in the documents underneath our application guide, lists out all the sequences in detail. It breaks down each section and kind of, I guess maybe you'd call English terms, kind of a more better understanding view of it there in that application guide. But then we've also got access to it through the application wizard when you're building out your projects. If you open up these submittal drawing packages in the application wizard, you can see the more kind of standard sequence that you would see on your construction drawings. And those are in those PDF drawings or DWGs, however you want to download and use those files for your control drawings. Those sequences are found there as well. So those are a couple different options as far as where to find these sequences and the details of what the canned application does or doesn't do. So we're going to move on and look at here the standard applications and as well as, what controllers they, currently fit into. We've got a fan coil application, heat pump, air handling, rooftop, unit ventilator, and a VAV. Underneath each of these, you can see you've kind of documented the controllers that they fit in. So some of these are our flex stats, our app stats have some of these applications, the 9300 series, Unitary controllers, right, that you can use for those rooftops. So they don't all fit into, everything, but you've got some options here. And then, of course, VAV application can roll into that back 9000, or it can actually be run through the 9300 series controller, a little typo there, to be used that way. If we were actually talking to a rep about using one of the 9300 series controllers and using a different actuator rather than the built-in actuator to the 9000 series controller. That is an option as well. I'm just using a standard 2 to 10 volt actuator to control your air damper. So, some details there. All right, let's dig in a little bit. Oh, hang on, let me back up one slide here. One thing I did want to mention with these is that these can be applied and selected through the Conquest net sensor or the Connect Lite. If you have controller with the net sensor that is tied together, you can do that through the menu there. The flex stack controllers that can be selected through the menu applications. So a couple different options there for applying these, not just necessarily connecting through Connect and applying those applications using Connect or Total Control. You can do it through a net sensor or through the menu on the FlexStat or AppStat. So
I could just add one little thing here, Fritz,
yep.
is you could in Connect, if you open up the device object and you open a chevron down there where it says applications, and in Connect, you can select it there, not just in the application deployment, if that made sense.
Yep, that it does. And we can look at that later too as well when we pull up Connect. So good note. Thank you, Gene. All right. So we'll talk a little bit about fan coil units. We've got the bullet points of the major points of these sequences. A lot of these are common across the different applications. So we'll go through them once, and then the ones that are kind of repeated through each of the applications, we're not necessarily going to touch on all of them going through it, but room temperature set points are pretty straightforward. Uses multiple temperature set points to manage a heating and cooling, active, occupied, unoccupied, standby set points. And these help to ensure good, precise control over the temperature fluctuations and different operational modes. Next up, we have our occupancy, motion sensing, and standby. Those are motion sensors are integrated to adjust room conditions dynamically. Gives system transitions to a standby mode if there's no motion detected. So it's different ways to kind of save energy there. The system mode and cooling changeover, cooling heating changeover. These are done based on set points and the environmental conditions. It can be automatic or manual. Both are available there. And then that changeover occurs right away when the conditions are met. Scheduling occupancy can be programmed to automatically shift between active and standby unoccupied modes. Again, it's just another feature that helps with energy conservation. Our dehumidification sequence that's available in some of these profiles, depending on if you have the associated, STE 9000, I think it's the 9021 net sensor that has the internal humidity sensor built into it. The dehumidification function regulates the humidity levels in the space, uses the set points and differential values to activate cooling and heating valves to maintain comfort. Couple notes there, the heating and cooling modes do need to be in automatic for that to function on its own. Also, it's not available in two-pipe applications. So our temperature sensing inputs for the fan coil is a space temp sensor. Obviously, that's pretty critical out of any of these applications to know what your room temperature is. In this one, we've got an option for discharge air temp, which is required for economizer control. We've got a water supply temperature sensor on the fan coil profile that's used for two-pipe systems to identify what the water supply is, whether you're getting chilled water or hot water. And it's important to note that calibrating and making sure those sensors are reading correctly is crucial for maintaining your building and room control. Fan operation and status. So we've got options with the fan coil unit for multiple speed settings. Modulating that fan speed is controlled based on space temperature deviations. The fan status is monitored to ensure we've got proper airflow and system operation. And then those different speeds and activation methods all just kind of contribute to an optimal climate control. We've got PID loops built into each of these applications. Those are just used to fine-tune that temperature control. And they help achieve a stable room temperature and by updating those outputs dynamically. Last but not least here, we've got valve operation. We've got some options of 4-pipe versus 2-pipe, on-off modulating, depending on what your mechanical setup is. It is important to note there on these valve operations that valve action can be reversed. For 2-pipe systems, the controller will use that water pipe or water supply temperature sensor to determine, again, if the chilled or hot water is being supplied. So we'll move up next to our heat pump unit. The set points, occupancy, system mode are all the same. One differentiation here with the system mode and changeover there, the changeover doesn't actually take place until after a fan delay there. The scheduling occupancy is the same. And I don't know if I talked about this before in the fan coil, but this is just going to be passed down either from total control, or if you've got it tied into a Niagara system, that occupancy command can be passed down and in. So the dehumidification set point or sequence is done the same again. If you have a humidity sensor tied in, that becomes available. Difference with the heat pump unit here, profiles, we have an option for an outside air temperature sensor, which is required for an economizer control in this application and required for that compressor lockout. Fan operation in the heat pump unit is 2 modes. It's either on or off. Same again with the fan status. It's monitored, to ensure you've got proper airflow and proper operation of your mechanical equipment. One thing to note with these, if the fan status isn't made within 10 seconds, those heating and cooling commands are stopped. Again, we've got our PID loops. One differentiation with this one was it's added a discharge air loop, which will control the economizer damper. And then we also have a reheat loop added with the heat pump unit, which is used only in the dehumidification. On these, we've got staged heating and cooling. The controller will manage the heating and cooling stages in the non-water-based systems. If you've got electric heat, gas, or DX units. And then we've got, again, the economizer. Economizer is enabled when the conditions are met. The economizer actually controls to the larger value of a minimum economizer damper position or the discharge air temp PID loop output that we mentioned a second ago in the PID loop section. If we do have one of our STE sensors with the CO2 connected to it, we can pull in and look at actual CO2 level to adjust the outside air damper to maintain fresh air intake. So you get a little bit of that demand control ventilation tied in with this as well. The reversing valve action can be configured as needed to be either active in cooling or heating, depending on what the installation is. And on this one, and I'm just noticing that the last bullet point is covered up by our logo down here, but we've got auxiliary and emergency heat action. So we've got some options for auxiliary heat. You can have compressor lockout, third stage of heat, or it's just disabled. We also have an emergency heat mode that's manually switched when the controller locks out of compressor outputs and controls the emergency heat on and off based on space temp. So that's our heat pump unit. Next, we're going to take a look at our air handler rooftop profiles, which are pretty much the same. I don't know if there's really much difference other than whether you're using staged heating and cooling or modulating. Again, we're using the same standard set points across the board, motion sensors for occupancy and standby. The dehumidification, same as the other applications. Temperature sensing inputs, we've still got looking at space temp, discharge air temp for economizer control. The outside air temp is required for economizer and compressor lockout. Fan status runs on the same as our heat pump setup. PID loops, we're running the same PID loops to control and get a good dynamic control of the space there. We've got the stage heating and cooling options as well. And then last but not least, the economizer control. Same controls as the heat pump unit, right? Controls to the larger value of the minimum economizer to damper position or what that discharge air temp PID loop output is. And again, with the CO2, if you've got it tied in, we've got an option there. Next up, with our fan coil unit, with our unit ventilator, sorry, I was thinking with our FlexStat option, we have a unit ventilator profile, which is the same setup as we have in the others. And actually, I don't think there's much difference between the unit ventilator as the others. So it's really just taking a look to see what fits your inputs and outputs the best and what controller fits it the best, whether you want to use the FlexStat on the wall or use one of the other controllers up at the equipment and use a net sensor in the space. We'll jump down here to the VAV profile. Again, pretty straightforward. It can be done with the 9000 series controller that we see pictured here, or you can use it with the 9300 series with the use of an external actuator. Room temperature set points, occupancy, system mode, all occurs and handles the same way. Our temperature sensor and airflow inputs, a little bit different. With these, we're going to be using pickup tubes to measure airflow with our high and low. And that's added there. If you had a discharge air temp, is required for heating applications, as well as mode change determination there. We've got PID loops built in to help kind of accurately determine what our needs are. The airflow set point sequence, right? If we do have a situation where there's no room sensor connected or for some reason the sensor gets taken off the wall, the VAV controller will maintain a minimum airflow set point. In normal operation, the cooling or heating loop will modulate to maintain the associated airflow set points. Whether it needs min airflow, max airflow, that's all done there. All the heating and cooling changeover is done just based on current set point and temperature. Changeover can be automatic or manual. With the VAV profile, we've got a safety feature built in, this discharge air temperature limiting, and that helps prevent excessive heating or cooling by maintaining discharge air temperature within a set range. With the VAV profile, we've got some reheat sequence built in that can be done with reheat coils of modulating reheat, electric reheat, or if you've got a floating tri-state reheat valve there, you've got some options there to use for those reheat situations. The damper operation, damper always controls to adjust the airflow based on demand. Dual duct systems, if you're tying in a separate and add in the 8000 controllers, the dual duct systems use separate dampers, right, for warm or cool air, and those are tied together. We've got fan operation that'll come on based on occupancy and different conditions, whether it's a parallel or series fan. What else? And then the last there, the dual duct, which we already talked a little bit about. Just using the separate ducts to maintain room temperature by mixing those two for the application. So we've got those applications. Now we're going to switch over here to connect. Just give a couple examples of using some of these CAN programs that are built for you and adding on to them. One of them will do building pressure and have it mapped into another controller. So let's see if we can pull up Connect here. Hopefully everybody can see my screen. In this case, let me scroll up here. Where's my VAV? So I've got a 9001 VAV at an open input on AI4 here. Just added a building pressure. I don't actually have a building pressure here on my test panel, but you get the idea. You can add that to your open input and bring that value in. And then in the case where, I would see this used is going over to another controller on your network. I've got an air handler down here, so I created a data pass program. And we're just going to use that net point cache to pull that in. Again, there's a few different ways that this can be programmed and written. In this case, I think whatever I copied this from has a couple odd values here. Oh, it didn't say. That's why it looks weird. So in this net point cache, I'm sure a lot of you have seen this. In this case, we would actually want to point this at my VAV controller. So I can put my device ID in here for my VAV controller. And I point it at the input. If I didn't map that to an AV in the actual VAV controller, I'd want to look at AI4 and my VAV controller, which is building pressure, right? So we're going to use that net point cache to pull that into my air handler controller here. And then from there, I can start a binary variable. Apologize, I thought I had done this earlier for y'all, but looks like live demos, always a little goofy. I don't know, say you want this greater than 0.25, this reading here, building pressure, then we would start a BV1 in our, excuse me, in our air handler controller to start a relief fan, or more than likely we would bring this in, map it to a PID loop in our air handler controller, which then could ramp an exhaust or a relief fan up and down for the building. Lots of options there, but the point being, we took a canned VAV application, used an open input on that controller. And so there's functionality and flexibility that you can use our canned applications to build onto to save you some time. So you're trying to make the best out of what's there. A second reference that I mentioned was using, I've got a rooftop controller, had an open output here, binary 4, didn't have anything wired to it. So I've got an exhaust fan command. So we've got that to be triggered on and off, and you can just build in, use it to reference your schedule object to trigger that exhaust fan on and off, or you can write a simple program to look at your occupancy command from the network, or if there's a separate, I don't know, exhaust fan schedule from total control, something like that, you can map that in and control that exhaust fan. So again, just using a standard application, rooftop application here, and we're using the free outputs to do additional control and simple little things that you can do. You can make this on up and as complicated as you want it to be. One thing that I think Gene had mentioned earlier, if we look at the properties of the controller, I believe at least this is where you were saying, Gene, was we can come in and look at our different applications here that can be applied to these controllers. Is that what you were thinking, Jane?
Yeah, it's in the device option. I can't see the screen, just so you know.
Oh, I gotcha. All right. Yeah, so we're just looking at the properties of the controller. And so we've got, in this case, 9311. So we've got the rooftop, heat pump, single duct VAV options of applications that can be loaded into this device. So those can be changed here or through connected net sensor. So we've got some options there.
Also point out that if you do some of your own custom programming and you decide you want to start over, you could go and select a different application and go back to the application that you were at, and then you'd get your original application that you started with.
Okay. I got you. So if you're going through and make some changes that maybe you don't like, right? You can.
Right. Yeah. If you did something and you change your mind, I never change my mind, but but I know.
Right.
Yeah. And if you believe that, so yeah, that's how you can start over if you want.
Perfect. Well, that sounds good. I don't know if anybody has any questions. I haven't seen anything come in the chat. Pretty straightforward topic that we're talking about today, but I think that just about covers it. Again, wrapping up here. As we go through these, always keep in mind we've got a bunch of great videos out on our KMC YouTube channel. Great material and stuff to watch out there. If you have any topics that you want covered, I'm actually going to start putting together a poll to send out to folks to send out questions and get some more feedback to see what y'all like to be covered. So keep an eye out in the next month or so for a poll to come through where y'all can provide your feedback. And if you have anything in the meantime, feel free to shoot me an email. And we will get that added into the queue of topics to cover for our Stuck on a Bucket. Our next webinar is going to be on Friday, March 28th. So keep an eye out for that. I'm hoping to get IT locked in to have a IT-based conversations for that one. So,
Fritz, did you see you got a question come in?
I did not. Let's see, where's the chat? How does the SimplyVAV fit into this? So the SimplyVAV, the application profile, all that information, right, will be the same as far as the sequences. With the SimplyVAVs, though, those are locked down, so you can't add anything custom to those. Correct, right, Gene?
That is correct.
Okay. Yep. So you can't add anything to those, like we did with these. Here, the controllers I was showing is our Conquest line. So those inputs and outputs are open to be configured and used as you see fit. So, but with the SimplyVAV, those are very specific functions to what they do, and so not much can be added to those, but they work great in the applications that they're built for. So, all right. Well, if there's not any other questions, we will wrap this up. Appreciate everybody for attending, and hope y'all all have a great day.
Yep. Everybody have a good day.
Perfect. Thanks, Gene. We'll talk to y'all next month.
Take care. Yep.
All right. Bye-bye.
Bye.